This is a discussion of rate laws for a zeroth order reaction, where a reactant A is becoming reactant B, but the rate does not depend upon the concentration of reactant A. The exponent on the concentration of A is the zero exponent, which means that the rate is constant. B is appearing at the same rate as A is disappearing, but the rate is independent of the concentration of A. Let's chart the change in A and B for such a reaction. The initial concentration of A is 1.5 molar, B is 0. In the first second, 0.05 molar reduction in A, 0.05 molar increase in B. Now, remember, the rate does not depend upon the concentration of A or B. So in the second, the rate is the same because the concentration of A is not affecting the rate. After 30 seconds, it's easy to see the reaction is over. The reaction is not dependent upon the concentration of A, and therefore there is no change in the slope of the concentration versus time line. A reaction rate study yielding a linear relationship between the time of the reaction and the concentration will indicate a zeroth order reaction. This is a very uncommon thing. There's going to have to be some other reactant involved. But if you see a linear relationship like this between the concentration of A and the time, you know you have a zeroth order reaction in that particular reactant. If you change the rate constant, you're going to change the time it takes for the reaction to complete, but the slope will still be constant. If you have a higher rate constant, the reaction will be over faster, but there's still no concentration effect.